In my previous video, I solved these two integrals, but I want to explain what these mean in terms of area. So when you have an integral from a to b, of f of x dx, yes, we get a number answer out, but what that number is it's going to find me the net area, which is the same thing as total area. Let's try that again. The net area between f of x and the x-axis from x equals a to x equals b. Okay, so what happens is one of the applications of integrals is that it finds the net area, and I'll explain what net area means in just a second. Okay, so what this is saying is that this function, 1 over x squared, if we graphed 1 over x squared, so 1 over x squared is this guy that looks like this, okay? And if I were to cut it anywhere, it's going to trap some area. So what I'm saying is that I'm going to cut it from 1 to 3. So I'm going to come in here and I'm going to cut it from x is 1 to x is 3. And I'm just eyeballing where those things are. As you can see, there's a little sliver of a shape that's in there. It's kind of like a curvy rectangle. And if I want to know what that area is, all I would need to do is integrate from 1 to 3, 1 over x squared dx, which, by the way, I already did. I got 2/3. So if you want to know the area that is in between the curve and the x-axis, I get 2/3. All right. Likewise, over here, 1 over x, what I would get, so the 1 over x graph splits, okay? And if I wanted to know the area that it's trapping from 1 to 3, it's a little bit fatter than my last picture, and that area is equal to the ln of the absolute value of 3. Pretty neat. Now, what do I mean by net area? All right, well, what if I had a function that, let's say, it bounces up and down? Okay, so part of that area is trapped above, and part of that area is trapped below. Well, what calculus actually does, what the integral does, is that area that's above is positive, and area that is below the x-axis is negative. So what the integral would actually do is take the area that's positive, add it to the area that is negative, and then give you the net result. Okay. We don't have to worry about the net area because the two examples that we did, it was above the x-axis, above the x-axis. But kind of the interesting thing here is that if we were to try and find the area over here on a negative region, what we'd expect to get out is a negative answer when I go to integrate. Okay, so just some things to keep in mind. Basically, don't panic if you get a positive answer out or a negative answer out, because what it's doing is it's finding the net area. In most of our homework problems, it's pretty much just positive area, but I just wanted you to be aware.